Today we're going over lesson 10.2 and 10.3. I'll do a little reminder about the operations with radicals, a little bit of what we did in section 10.1. And then today we're looking at special right triangles. They're the right triangles that have special angles like 30, 45, and 60. You will need a calculator. If you don't have one, please make plans to borrow one today. As I record this, a reminder to you that I'm going to pause at times, but probably not wait long enough for you to write everything down. So press the pause button, write down what you need to, and then start back up again. First, I want to do a short review of some of the simplifying radicals and then taking a look at squaring radicals and multiplying radicals. Okay, when we did simplifying radicals on Friday, we took that square root of 80, and then we did the factoring tree. We went way into primes. We might go 8 times 10, 2 times 4, 2's prime, 2 and 5 are prime. The 4 was not prime, so factor it. Then what we did was looked at the pairing. Okay, so we thought square root of 80 is, now put them in order, 2 times 2 times 2 times 2 times 5. So pair up, there's a pair of 2's, that comes out of the radical. Another pair of 2's comes out. There's a 5 that cannot go out. So we end up with 4 times the square root of 5. Okay, now do the square root of 45, the next example up there. Okay, hopefully you paused it and worked through it. If not, pause this. Square root of 45 would be 9 times 5, 3 times 3. These are your primes. Square root of 3 times 3 times 5. So the 3's paired up, so a 3 comes out, square root of 5 does not. Square root of 45 simplified is 3 times the square root of 5. On Friday we didn't look at squaring radicals for very long, but let's try this on your calculator. Square root of 5 squared. You probably have to put in parentheses before the square root of 5. A lot of your calculators come up with a square root or a parenthesis in the square root. So you would need to put the 5, finish that square root, finish the square root you started with, and then square. That's the real proper way to get it to work correctly. It should show you that that equals 5. Why does that really equal 5? Well, it's the square root of 5 times the square root of 5, which is the square root of 25. That's a perfect square, which is 5. So squaring a square root, you end up with that radicand number. If we would do something a little bit more involved, like 4 square roots of 3 squared, again, you could try it on your calculator and see what it gives you. Writing it out, 4 times the square root of 3 and 4 times the square root of 3. We can actually multiply the 4's together and the square root of 3's together. So we get 16 times the square root of 9. The square root of 9, that's a perfect square. So 16 times 3, we should be getting 48. Again, get the parentheses in there. If you needed to do it with adding parentheses, you would go 4 times the square root of 3, finish the parentheses, finish the other parentheses, and square it. been multiplying radicals. You might have seen me multiply in those last sample problems. But square root of 10 times the square root of 2 is simply the square root of 20. Actually, on this one, we're not completely done because square root of 20 can be simplified. 2 times 10, 2 times 5. We have a pair of 2's. So 10 times the square root of 2 becomes 2 times the square root of 5. Look at all the steps that were involved there. So you can multiply square roots together, but then you have to consider whether you can simplify. Next example, square root of 8 times the square root of 2. Multiplying those square roots together, 8 times 2 is 16. Now if you recognize the square root of 16 as a perfect square, 4 and you're done. Next problem. Now if you didn't see that, 4 times 4, 2 times 2, 2 times 2, you've got 4 2's. Pair, another pair, so you will get the 4, but just takes you a little bit longer. Right, and the last example I have on this screen, 6 times the square root of 5 multiplied by the square root of 3. Don't have anything I can multiply the 6 with, but the 2 square roots can multiply to be square root of 15. Not a perfect square. Think about factoring. It's the 3 and the 5 that you had. You might notice that there's no pair at all. So there's nothing that's going to come out of the square root of 15. So this one actually can't be simplified. It's just 6 times the square root of 15. So you can do the multiplying, look for reducing. That's some review things on radicals. Now in lesson 10.2 and 10.3, I said we were going to use special right triangles. So one special right triangle is called a 45, 45, 90 triangles. It is an isosceles right triangle. So the two legs are congruent. Isosceles triangles, if there's two angles, like the base angles that are congruent, then the sides across from each of those are congruent. So that might help you see that it is an isosceles right triangle. I'm going to give you side lengths and have you calculate the hypotenuse, and I want you to reduce it as a radical. So let's take this side as 3. This side's also going to be 3. Now, how can you find the hypotenuse? We've done the Pythagorean theorem, and that's what you should be able to use. Okay, so take a little bit of time and calculate with the Pythagorean theorem, and then simplify in radicals. I didn't really lay out the paired up part, but up from the tree, can you see there's a pair of 3's and there's an extra 2? So our hypotenuse became 3 times the square root of 2. Now in class, we would have done multiple ones. I'll show one more. Keep in mind that that was 3, whatever I gave you to start with, multiplied by the square root of 2. Get rid of all this. Okay, I'm going to start you with a different number. let's say that the legs are 4. 4 and 4. So Pythagorean theorem. 16 and 16 is 32. So C is the square root of 32. Factoring, let's see, 2 times 16, 4 and 4, kind of running out of room. 2, 2, 2, 2. How many 2's do I have? Looks like there's 5. Okay, so there's a 2 that goes out. There's another 2 that goes out. And there's a 2 that doesn't have a partner. So we end up with 4 times the square root of 2. Remember on the last one I had 3 and 3, and 3 times the square root of 2 was the hypotenuse. Here the legs were 4 and 4, and 4 times the square root of 2. There's a pattern of what the hypotenuse always comes out to be in this type of a triangle. It always is whatever the leg length is multiplied by the square root of 2. So the theorem, you're going to have to pause the screen because there's a lot on there. I might talk about some of it, but pause it so that you can get everything written down. Okay, so this is what I'm saying on that triangle. This triangle looks a little tall and skinny. But on the picture I have the 2 legs are the same, x and x. The hypotenuse comes out to be x times the square root of 2. So I wrote it out in words like the theorem says. The 2 formulas off to the side, these 2 are very important for you to have in your notes because that's what we're going to look back to each time to see how we find the hypotenuse or how we find the leg. You're either multiplying by the square root of 2 or dividing by the square root of 2. So get this all written down, then start the presentation again. Okay, let's have you find the missing hypotenuse. Now, easy ones, notice I've marked isosceles. Let's say this leg is 6, this leg is 6. Now, if you know the pattern, to get the hypotenuse, you take the leg length times the square root of 2. In radical form, we would be done right now. Looking at the directions, it says rounded to the nearest tenth. So grab your calculator. 6 times the square root of 2 to the nearest tenth would round to be 8.5. So you took the leg length and multiplied by the square root of 2. Now on the second one, I'm going to give you a radical for the leg length. Let's say this length is the square root of 5. Then the next side is also the square root of 5 because those 2 legs are the same. The hypotenuse is that leg length times the square root of 2. Again, we talked about multiplying. That would be the square root of 10. The directions here say rounded to the nearest tenth. So the square root of 10 rounds to be approximately 3.2. The hypotenuse is always longer than the leg. If you don't know, if that doesn't seem right on the second one that we did here, the leg's square root of 5 is about 2.2. So the legs were about 2.2 and the hypotenuse happened to be 3.2. Okay, so to get the hypotenuse, what I did on both of these is I took the leg length, doesn't matter which one because they're the same, and I multiplied by the square root of 2. Followed the directions to see what it told me. Now we're going to start with the hypotenuse and find the leg length. So if you look back at your notes, to get the leg on this kind of a triangle, we'll take the hypotenuse and divide by the square root of 2. Find the missing leg length. Whether we go to decimal or not is going to depend upon what I give you to start with. Okay, now remember your two legs will be the same. I'm going to give you the hypotenuse as 8 times the square root of, whoops, I don't want the square root of 3, I wanted the square root of 2. Okay, now to get the leg, you have to take the hypotenuse and divide by the square root of 2. On this problem, I actually made it nice because the square root of 2's can divide out. And so you'll get just 8. Try that on your calculator. 8 times the square root of 2 divided by the square root of 2. Did you get 8? So that type of a hypotenuse length gave you a real nice leg length. Now if I start you with something like just 10, to get the leg, you still do the dividing. 10 divided by the square root of 2, but I don't have a square root of 2 in the top to cancel with. So on this type problem, they will definitely have you do decimal. So 10 divided by the square root of 2 comes out to be, let's go nearest tenth, like on the last screen, 7.1. So both legs were about 7.1 because they were the same. So if you start with the hypotenuse to get the leg, you divide by the square root of 2. Okay, so let's have you try a little quiz here, a check of understanding. I'm going to give you, on the first one, I will give you 15 for the leg measurement. And on the second one, I'm going to give you 22 for the hypotenuse. Okay, so find the missing side measurements on these two triangles. If it seems like you need to go to decimal, go ahead and round to the nearest tenth. Pause the presentation and work the two problems. Okay, coming back, the legs would be the same, so this side's 15. If you really wanted to, you could do Pythagorean theorem right now, but if you recognize that this would be a 45-45 triangle, the hypotenuse is the leg length times the square root of 2. If the directions say radical form, there's your answer. If it says you could go to decimal, we would go approximately 21.2. Now in the second triangle, 22 is the hypotenuse. So to get the leg, you're going to take the hypotenuse and divide by the square root of 2. There's no square root of 2 to cancel, so go ahead and do this one in decimal. 22 divided by the square root of 2 is about 15.6. So each leg here was approximately 15.6. All right, that's our one of our special right triangles. You'll find it on the formula wall, probably about in the middle of the classroom, middle of that wall. The second one is the triangle right below it. I've got it turned differently on the smart board than what is on the wall, but the pattern is the same. Okay, when we talk about this one, we have to name the shorter leg, longer leg, and hypotenuse in order to understand what I'm talking about. So the hypotenuse, remember, is always across from the right angle. Okay, so across the triangle, that's the hypotenuse. Now the other two sides that make the right angle are the legs. But if you look at my words, we have to figure out which one is the longer leg and which is the shorter leg. Now you can probably look and tell that this bottom one is the shorter leg and the one going up is the long leg. But here's how you can tell where those are, especially if you draw a picture that doesn't look very good. remember that the smallest angle is across from the shortest side. So if this 30-degree angle is at the top, when I go across the triangle, the leg that is shortest will be across from it. So then 60 degrees across from it, that's not the longest side of the triangle, but out of the two legs, that is the one that is longer. So the long leg, short leg, and hypotenuse. On the screen it says the hypotenuse is always twice as long as the shorter leg. So if the shorter leg is 8, the hypotenuse is 16. Hypotenuse is always twice as long as the shorter leg. Then if we calculate the length of the longer leg using radicals, we can get what the pattern is. I kind of gave you a big number to work with. But let's try the Pythagorean theorem. I'm going to try and delete part of this so that I have room to work. I'll just delete this right now. Okay, so to get the long leg figured out, Pythagorean theorem, 16 squared is 256. Subtract 64. Okay, so that missing leg is the square root of 192. Kind of a big number, but let's see. I think I can divide it by, let's go bigger than 2. I'm going to try 8. 24 and 8. That'll just get me to the factoring a little bit faster. And I have room for it. Okay, looks like I've got, scroll it up a little bit. 1, 2, 3, 4, 5, 6 2s and a 3. So pairing, there's a 2 that's out, there's a 2 that's out, there's a 2 that's out. 3 doesn't have anything to go with it. 2 times 2 is 4, times 2 is 8, times the square root of 3. That took us a little while to get to, but this long leg, the length is 8 times the square root of 3. Notice that that is the short leg times the square root of 3. That is the pattern that happens on this kind of a triangle. The hypotenuse is always twice the short leg, and the long leg is always the square root of 3 times the short leg. So here are your notes, a lot on the screen. You'll need to pause so that you can get everything written down. It's in words, it's in a picture, and again, these formulas will be important for us so that we can multiply or divide by the right thing to find the missing measurements on the next examples and on your homework. So get everything written down and then start this up again. Okay, so I'm going to start you with the short leg and have you find the other two sides. Let's say this short leg is 5. So then the hypotenuse was the short leg times 2 on this kind of a triangle. So that's 10 for the hypotenuse. And the longer leg is the short one times the square root of 3. Only way I would do that is if it allows me to go to decimal. So this is about 8.7. Okay, let's start with the short leg. Let's say the short leg is 18. Figure out the other sides and then check to see if you did it right. Hypotenuse is short leg times 2, which is 36. Long leg is short leg times the square root of 3. In decimal, 31.2. Okay, so now what if we don't start with the short leg? Well, if we don't have the short leg, we want to find the short leg. So let's start with the hypotenuse. Let's say the hypotenuse is 30. Let's go 32, so you don't think it's the same as the angle. Okay, 32. So now to get the short leg, you take the hypotenuse and divide by 2. 32 divided by 2 is 16. Now to get the long leg, look in your notes what it says. Short leg times square root of 3. In decimal, 16 times the square root of 3 is 27.7 approximately. If I start your hypotenuse with an odd number, let's say it's 15. The short leg is half of that. 15 divided by 2 is 7.5. And then the longer leg is that short leg times the square root of 3. 7.5 times the square root of 3 rounds to be, well, you have to round up on that, 13.0. Do put the 0.0 so we know that it was rounded. Now, the last type of problems would be starting with the longer leg. Now, the easiest way would be if I start you with 4 times the square root of 3. That looks like a messy length, but you want to find the short leg. So short leg, if you know the long leg, look at your notes there, your formulas. If you have the long leg, you're taking that measurement divided by the square root of 3. This actually works out nicely because the square root of 3's divide out and we get just 4 for the short leg. The hypotenuse is always the short leg times 2. So 4 times 2, 8 for the hypotenuse. So that one I gave you a square root of 3 in the measurement to start with. Now on this next one, I will not give you that. Let's say the longer leg is just 10, not 10 times the square root of 3. Short leg still, if you know the long leg, you get the short leg by taking the long leg and dividing by the square root of 3. It doesn't cancel out in this problem. 10 divided by the square root of 3 is rounded to be 5.8. Now the hypotenuse, now that we know the short leg, hypotenuse is short leg times 2. 5.8 times 2, 11.6. So what we did was we divided by the square root of 3 in order to go from the long leg to the short leg. The key to the 30, 60, 90 triangles is finding the short leg. Okay, so those notes, I'm going to flip back. On the one that we were just doing, hypotenuse is found one way, long leg is found one way. There are 2 ways to find the short leg. It depends upon what measurement you have to start with. If you have the hypotenuse or if you have the longer leg. If I go back a little bit further, remember we had a different kind of triangle to start with. We had the one that had the isosceles triangle, 45, 45, 90. For that one, you were multiplying or dividing by the square root of 2, because there's just two different lengths in that triangle. That's how I remember that it's the square root of 2 and not the square root of 3. Where you have the square root of 3, there are 3 different lengths in that triangle. All right, you will receive what the assignment is and work on that for tomorrow. Show your work, use the calculator if it tells you that you can go to decimal. If it says radical form, that probably means it was an easier problem and you can just leave the square roots there. Okay, if you have some questions, we'll talk about this some more tomorrow.